Hi, how are you guys? Today we are talking about GLBP protocol. GLBP protocol, it's a Cisco proprietary protocol. As we know, we have three redundancy protocols, HSRP protocol, VRRP protocol, and GLBP protocol. In this video, I will speak about GLBP protocol. It's a Cisco proprietary protocol, as we said before. But GLBP protocol, it's quite a little bit different from HSRP protocol, because HSRP protocol, if you remember, if I want to make a load balance between these three routers, and I have 5 PCs here, I have to add in each PC different IP virtual gateway. But in GLBP, I have just one IP virtual gateway. I have this virtual gateway, and I have a different or many different virtual MAC address. So here is the trick. The trick is each PC 1, 2, 3, 4, and 5, each one of them has a specific virtual MAC address, and this virtual MAC address it's responsible to make load balancing. So before I get started, I want to explain some informations about GLBP also. In this video, it will be step-by-step video to understand GLBP with a very good explanation. I will take all possibilities to explain GLBP. We will have many scenarios and many troubleshooting in these videos. So I hope this video to be good for everyone who wants to know about the GLBP. As we see here in this topology, we have 3 routers here, 1, 2, 3. Let's suppose it's edge routers, and I have here 5 PCs, and I have one router 4. I will use it as a destination. I want to make ping from PCs here to the router 4 through this to this IP address. A little bit information about the GLBP. GLBP here, it's act as HSRP. It's the same, but in different terminology. What I mean that if I want to make a router 1 is the active router, I want to use the highest priority. The same in HSRP. HSRP, the active router, it will has the highest priority, and the second one, it will be the backup or the standby. So in GLBP, I will use here router 1 the highest priority, so I will make it AVG. So what is AVG? AVG, it's active virtual gateway. This active virtual gateway, it will be responsible to receive all ARP requests from all PCs. All ARP requests from all PCs here. From the first time, it will go through this router, and AVG, it will respond or reply with ARP response with a virtual MAC address for each router here, for each PC. So AVG, it will be the active router, and it will be the responsible to respond or to reply for virtual MAC address. Also, AVF, it means active virtual forwarder. Also router 1, it will be the active virtual forwarder and active virtual gateway at the same time. Router 2, it will be the actual virtual forwarder, and router 3, it will be in the listening state. So is there any information to? Yes, I want to use the wait. As we know, we have many ways to arrange the virtual MAC address. Here I want to use the weighted, so I want to use the highest weight in router 1, the second in router 2, and router 2, then the last one in router 1. So what does that mean? That means is if PC2 start to ping to this destination, it will send the ARP request, like here, to the router 1. Router 1, it will respond with ARP response, yes, with a virtual MAC address of router 3. Why? Because router 3, it has the highest weight. And the second one, let's see, maybe the PC1. PC1 sends ARP request to the router 1. Router 1, because it's the AVG, it will send with ARP response with the MAC address, virtual MAC address of router 2, because router 2, it has the second highest weight. And also PC3 send also the ARP request, yes, to the router 1. Router 1 will respond with ARP response with the virtual MAC address of router 1, because the router 1 is the last one of weight. So I want to use weight here to control distribution of virtual MAC address. Also, I have by default it's robin. Yes, by default it's round robin. Yes. So also in this topology, I want to show you how can we track. Yes, if this fast Ethernet or this port goes down, how this track. And so this is the information, and we will go to the explanation and configuration. So let's get started. Now I am in router 1. As we said here, I want to make router 1 the AVG, so I want to use the highest priority, and I want to use the lowest weight. Conf-T. So interface fast Ethernet 00, because this I want to show you. Here is, yes, fast Ethernet 00. So now just 7 minutes, that's good. So GLBP 1, the IP virtual IP gateway, this 10.0.0.5 30.50. Also GLBP 1, look at this. So I make a debug GLBP events, so we will see every step here. That's good. Now GLBP 1 with priority, I said the highest priority, I want to use 110. So what do you think to undebug all, just to see the configuration clearly? Yes, I think on debug all, just I want to stop the debug GLBP to see the clear, yes, to see the clear configuration. I add what? I add the last one, priority, yes. So now I want to specify the weight. I want the lowest weight, let's suppose it's 5. And what we want to do also, GLBP, yes, 1. Load balancing by weighted, yes. I want to based on weighted, as we see here, just question mark. Look at this in route robin by default. I also have host dependent and weighted. Here's I want to use high weighted. So now GLBP 1, is there anything here? So I think until now it's enough. Let me show run interface fast Ethernet 00. Let me show this. That's good. 110. This is the default IP virtual gateway. So that's good. Let's save it. Now go to, just I want to show you something before I go to router 2 show GLBP here. Look at this. I have this router is active, yes, with this virtual IP, and also standby is unknown because I didn't complete my configuration yet. Also, I have this active is the local, so this is the AVG router, yes, because it has the highest priority. The default priority is 100, remember. And also weighted, I configure 5. The load balancing is based on weighted. I have one forwarder for this router is active with weight 5, and the active router is local. Look at this. Here is the virtual MAC address. This router, it has virtual MAC address by default. Here is, we see, and here is the MAC address of fast Ethernet 00 of router 1. Here's this MAC address for this interface. So now let's go to router 2. Sorry, what is router 2? I don't have router 2 here. Yes, no problem. Console. So let's see here. Show run interface fast Ethernet 00. Yes, I don't have anything. So conf t interface fast Ethernet 00. I have GLBP 1 virtual, the same virtual 50. GLBP, the same group number. So here's I have also the debug GLBP, so I don't want to now and debug sorry, all, yes, conf t interface fast Ethernet 00, GLBP 1 with priority yes, with the priority 100, GLBP 1 with the preempt. Oh, so you see, maybe I forgot the preempt in router 1. I didn't add preempt. Let me see here. Yes, I forgot preempt. Yes, it's added here because it's very, very important. So I want to show you why. GLBP 1 preempt. This command, it's very important. Why? Because let's suppose router 1, this fast Ethernet goes down, and then the router 1 will lose its priority to be a AVG. So router 2 will take over the AVG. It will be AVG. So let's support router 1. It's come back again. Maybe someone fix it or something like this. If I don't use preempt, the router 1 will not come back again to be the AVG because it's not have a preempt. So I want to add this command to make router 1 to go back again or to be the AVG. So this is a good information. Be careful about this command. GLBP, sorry, 1. I did a priority preempt, also weighted. I want this 6 because I want to the second one. So GLBP, I want to make load balancing based on weighted. So everything here is complete, I think. Show run interface fast Ethernet 00. So that's good. Yes, make save configurations. Let me go to router 1 and show GLBP again. Look at this. Now we have a standby. Standby, it will be this router, this interface, because it has a priority 100. And here I have 3 forwarders also. The second one is the listening state. Look at this. Show GLBP. Here is we have standby. This is the standby. And also forwarder 1 is the listening. Forwarder 2 is the active because it has the weighted 6. Look at this. The active router is local. And the active is 10.0.0.1 with the primary, because the primary, this router is the AVG and it has the weighted 5. So now let's go to router 3 and complete the configurations. Enable. I hope this video I want to cover everything about GLBP, so I hope to be good for you. So now go to conf t interface fast Ethernet 00. Sorry, what's IB? GLBP 1 IP 10.00.50, and now GLBP 1 with the priority, with the priority 90, because I have here 110, 100, and here is 90. So GLBP also 1 with the prompt. GLBP 1 weighted is 7. GLBP 1 load balancing based on weighted. So now I have everything here is good. I think it's okay. Let's go to router 1 and make another show GLBP. Look at this. Now I have forwarder number 1 here. Look at this, forwarder number 1, and I have here active is local. That's good. Forwarder number 2, it's look at this. I want to show you something important. This is the virtual MAC address of router 1, and here is the forwarder number 2. He said I learned this MAC address or this virtual MAC address from the AVG. Also forwarder number 3 in router 3, he said I learned this virtual MAC address from the AVG, and here is in the listening state. That's good information. And also the active for router 3 is 10.0.0.2. Here is the secondary active. Yes, and for router 3, which is the secondary, and weighted is 6. And let me show you also here. Show GLBP on router 3. Look at this. The forwarder number 1 is in the listening state. Yes, because it has not listening state. It depends on router 3. And also here is the router 3, forwarder router 3. Yes, look at this, state is active because it's specified for router 3, and here is the virtual MAC address for router 3, and this local is active, and weighted is 7 because we configured weight 7 for router 3. So that's good. Now we will have a fun, and we have to test our configuration. I want to go first to PC2. I want to close everything here because I want to start from the beginning. Yes, PC3 here is closed also. Yes, now PC2. Go to PC2 and what is that? Yes, show ARP just to make sure. Yes, maybe I have many here. I don't want to show any ARP here. I want to interface fast Ethernet 0.0. Sorry, what is that? Yes, so I want just to use shutdown. Just wait a second to apply shutdown, and then no shut. Yes, that's good. Show ARP. Yes, I don't have anything here. I want to use debug ARP to see the ARP request and ARP response. So I want to make a ping to 25 here to this interface. Yes, 25.0.0.4. Because I hit enter, I want to say PC2, it will send ARP request, yes, to router 1 AVG, and router 1 AVG, because it's the AVG, it will send the ARP response with virtual MAC address of router 3. Now, not for router 1, for router 3, because router 3, it has the highest weight. So now let's see. That's good. Look at this. Here we have the virtual MAC address of router 3. Yes, that's good. So now show ARP. Yes, that's good. So if you did the trace route to 10.0.0.4 and to show the path, we will see the path. It's go through here, through router 3. Just be patient. Yes, come on up. Problem because I have debug ARP. That's good. Just let's see what's. Yes, look at this. We have this gateway. Here's. Yes, the packets goes through this route. That's good. So as we expected. So go to PC1. Let me see. Show ARP. I don't have anything here. I want to make debug ARP to see the syslog of this command. Now go ping 10.25.0.0.4. Now look at this. We must, or we should have a virtual MAC address of router 2. Here is a virtual MAC address of router 2, 102. Look at this. That's good. That's very good. So go to router PC3 and also make a ping. Show just to make sure nothing. So debug ARP ping to 25.0.0.4, the same destination. So now it has to take the virtual MAC address of router 1. Here's the virtual MAC address of router 1. So that's good. I love this because it works as we want from it. So that's good. So what we supposed to ping also here, we exceed the 3 PCs with 3 routers. If we have another PCs, it will start again from router 3. If I ping from PC4, it will come again from router 3. It will has the MAC address, virtual MAC address of router 3, and also 5. It will has the virtual MAC address of router 2, and also if I have another PC. So it depends on waiting. So that's good. That's very good. So now we knows this. So I want to show you something. If this fast Ethernet goes down, the router 2, it must be the AVG. So let me see here. Go to router 1 and conft. Now interface fast Ethernet 00. Just I want to make it shut down. Yes. Just is anything here? Just wait. Just show GLBP brief. Look at this. It's in the init state or initial state. The standby, it's unknown until now. Look at this, it will not be. Show router 2. Go to router 2. I will want to show you something. Show GLBP brief. Look at this. Look at this. Fast Ethernet 00. It has a priority 100. Okay, it's the lower than router 1, but router 1 now it goes down, and because I used preempt here, it becomes the AVG, and the standby router, it becomes 10 to 10 to 10 to 3. This router become the backup, and router 2 the AVG. Let's go to the router 3 and to see if this is correct. Show GLBP. Look at this. Now router 3 is a standby. So that's good. Now I want to router 1, and to make it no shutdown, I want to just to recover the fast Ethernet to go work, to come back again. So interface fast Ethernet 00, no shut, because I use the preempt here. Remember, it will become the AVG again. I will take over again. So look at this. I want to use GLBP brief. Look at this. It's become the active again, and the standby here is 10.0.0.2. So that's good. So the operation now is good. It's working. So the final one I want to show you here. Let's suppose if I have this fast Ethernet goes down. Router 1, the AVG, it will not learn about this. So it will use the path. If I want to make a ping from PC3 to PC4 to this destination, it will go through here and it will take a long time. Router 1, it will go forward to router 2, and router 2, it will go to router 4. So this will take a long time, and maybe it will make a loop, make a problem in your network. So I want to make a track. Using weighted. I want to see if this, hey router 1, be careful and keep in your mind, if this fast Ethernet goes down or is something wrong in this line, just decrease the weighted to 0, yes, and take over your action to router 3. And every PC here has the virtual MAC address of router 1, it will go to the router 3. So how I can configure this issue? We will go to router 1, and here is, you have two choices to configure this. You have to choose IPSLA and use ICMP EQ, yes, to the fast Ethernet with this source and with destination of anything, and attach it with GLBP track. But here I want to use the weighted and the lower and upper weight, so I want to use conft. First of all, I want to use a track. Here's track with track object number. I want to use 1. Now I want to use a track. I want to use here router 1. Be careful. Track to fast Ethernet 01. If it's shut down or something wrong, so wake up. Like this, interface fast Ethernet 01. Yes, here's, I have two choices. I have IP routing or I have line protocol. This means if line protocol goes down, so track working, and also if IP routing goes down, also work. So I want to use here IP routing. Yes. So now exit. I don't want to use anything here. So now go to the interface fast Ethernet 0 now. Interface, yes, and use this GLBP 1 with weighting 5, because I have weighting 5. Here is low. Look at this. Lower, I want to use lower 3 and upper 4. What does that mean? This means that I want to make weight number 5, because I have the weighted here 5 and 6, and here is a 7. I want to use 5, lower 3 and upper 4. What does that mean? This means if the weighted is minimum or the weighted is less than 3, yes, it will become also don't take over. And also if the weighted become more than 4 and recover back again to 5, then router 1 will take over and go naturally. So I want to go this. I have another last one weighted. Look at this. Here's, I want to use track to attach track number object number 1, and also here what we have, decrement value to 5. So what does that mean? This means if fast Ethernet 00 goes down and the track is working, so now decrease or decrement the weighted value 5 to become 0. So now, because before I did this, I want to make a debug GLBP events just to see what's happening here. So let's see here in PC3, as we see PC3, it used the router 1, I think. Yes, PC3, it used the virtual MAC address of router 1. If we see here trace route, 125.200.4, just to see the path. It will go through router 1 here. You will see here it will go through router 1. Yes. Come on, give me some shooting. Come on up. Yes, look at this. He goes through router 1. So let's suppose, let's this finish also before yes. So let's suppose this fast Ethernet 01 goes down for some reason. So router 1, 1.2, FT, interface fast Ethernet 01. So shut down, game over. Look at this. Look, the weighted, it's converted to from 5 to 0. So weighted here now is 0. So who will take over? The takeover, it will take over this router, router 3, because it has the highest weighted. So look at this. I want to show you something. Show GLBP router 1. Look, I have weighted, I configured 5, but now is 0. The lower is 3 and the upper is 4. That means if the weighted becomes more than 4, it will take over again and will work properly. So now I want to show you something here on router 2. What's happened? So show GLBP here. Look at this. It will take a time. Yes. Yes, to take it. Yes, come back again, but just take time. I don't want to waste your time. So now look at this. The active forwarder number 1, it become, look what is the active. We are in router 2. Look at this. The active is 10.0.0.3. It become the secondary one. Become the secondary with weighted 7. So every PC here has a virtual MAC address of router 1. It will go through router 3. For example, here we will go to the PC 3 and make a trace route. Look at this. It will use this router because here, remember, it has a 001 here. If we go up, yes, look at this. Sorry. It will has a virtual MAC address of 001. What is it? Here's look. It has this IP address, so no problem. It will just to see which. Yes, look at this. It go through 0.10.0.0.3. Look at this. That's good. So because this router is go down, so because this fast Ethernet in router 1 goes down, also the router 3, it will be take over this action, and each PC has a virtual MAC address of router 1, and it will send the route to the router 3, not to the router 1, because this fast Ethernet goes down. So let's suppose to router 1 to come again, the router, see if someone fixed this interface and come back again working. So let's see this, the weighted from 0 to 5. So yes, now 5, it's larger than, or it's greater than 4. So this router, it will take over the action again. So go to router 2. Here is, you see here, the active is 10.0.0.3 is the secondary. It has the weighted 7. So now, let's see, show you something. Show GLBP. Maybe it takes a time. Just wait a second. Yes, look at this. The active forwarder 1 is, yes, for router 2 it become the primary. Router 2 become router 1 is the primary. It's come back again. So that's all thing. We talked about AVG and AVF. We talked about the listening state. We talked about the tracking. This is a very important thing. We talked about also about the preemption. And I think, or I hope to this video to be good for you to understanding GLBP, and try to imitate this topology in your PC. And if you have any question or have any explanation or have any interpretation, just visit my LinkedIn profile, and I hope from everyone, or on Twitter also, and I have everyone to be happy with this explanation. So that was that, and have a good Friday. So bye bye.